have two ways we can classify triangles. We can classify them by angle measure, and we can classify them by side length. So we'll start with by angle measure, and we have an acute triangle in which all angles measure less than 90. You can remember this because they're cute little triangles, so they're acute. Okay. We have an obtuse triangle where you have one angle measures more than 90. And it can only be one angle. There can't be more than one angle that's larger than 90 degrees in a triangle. There can only be one. You have equiangular, where all of the angles are the same. And they all equal 60 degrees. And then you have a right triangle where one of the angles it measures exactly 90 degrees. So you have a nice little, well, that's an equiangular one. Never mind, hold on, let me move that one. Nice little equiangular triangle. Here's a lovely right triangle. We'll pretend that that's not 90. And we'll say that's 89 degrees. So they're all less than 90. And then we will do an obtuse triangle, where we'll say that this one measures, well, we'll just say 120. This one measures 61, and we'll say this one measures 30. I have no idea if that's what they actually measure. I'm just making stuff up. But they're all less than 90. That's the point. With the obtuse, you have one that's more than 90. These will all be 60, and then this one will be 90. And we have 360-degree angles. So what kind of triangle is this? Equiangular. Okay, angle 2. Yeah, obtuse because we've got one that's greater than 90. Angle 3. Right, because we have an exact 90-degree angle, so that's a right triangle. Acute because they're all less than 90. Obtuse because one's greater than 90, and acute. Classifying by side length. Equilateral. Equa meaning equal, so all sides are the same length. Then you have scalene, where you have no sides are the same length. And then you have isosceles, where you have two sides are the same length. Okay. Now when we look at triangles, see these marks here? If you have the same number of lines on a side, that tells me that the side lengths are the same. So if I have a triangle here, equilateral, I'm going to have all three the same. If I have scalene and they're actually marked, I'd have a different number of side lengths, different number of lines to show that all three sides are different lengths. or I would have no marks at all. And then isosceles, two sides would be marked the same, either with like one line or two lines, but they'd have the same number of lines. Okay, so when we look at triangle ABE, we're looking at this triangle here, A, B, and E. I have a 9, a line, and an 8 times the square root of 2. So none of those match, so we're scaling. Triangle EDB, so EDB, I have 2 lines and an 8 times the square root of 2, so 2 sides match. So I'm isosceles. Oh, and this is on your worksheet, sorry. You don't have to draw the picture. E, B, C. So we're looking at the large triangle that's made up of the 2 smaller triangles. I have an 8 times the square root of 2, I have a single line, and then I have 2 single lines, which would make that not the same length. So it's scaling. And then lastly, I have DBC, where I have 3 of them with a single line, so that's equilateral. Now, with polygons, other than triangles, you can be equiangular and not equilateral, and you can be equilateral and not equiangular. If you're a triangle and you're equilateral, you're equiangular. If you're equiangular, you're equilateral. So in a triangle, you're both at the same time. So what we do typically is you won't hear a lot of people saying, oh, an equiangular triangle, because equiangular is kind of harder to say than equilateral. So typically speaking, it just gets called equilateral. So when you see equilateral triangle, you can know it's also equiangular. They're in a triangle, it goes both ways. So we're going to go back and look at these same triangles, and we had ABE, and you see how it has a right angle. So we would call this a right scaling. Okay. EDB, this is bigger than a right angle. Angle D, you can see that it goes beyond 90 degrees. So that would be an obtuse isosceles. And the angle part comes before the side part. You wouldn't call it an isosceles obtuse, you'd call it an obtuse isosceles. EBC, we have that right angle. So that's another right scaling. And then equilateral is also equiangular, so you wouldn't say equiangular, equilateral, you just say equilateral. You can have a right isosceles. So you can have a right isosceles or a right scaling. You can have an obtuse isosceles or an obtuse scaling. You can have an acute isosceles or scaling. What you cannot have is an acute equilateral. Well, actually, that's not true. It is acute. Sorry, they're all less than 90 because they're 60. So it is acute. It's just, you wouldn't say equiangular, equilateral. You could say acute, equilateral because they're all acute because they're all less than 60. You could just leave it blank, unless it specifically said, like in one of your answer choices, acute equilateral. What you cannot have is an obtuse equilateral. You cannot have a right equilateral. If it's an equilateral, it can only be acute because it's also equiangular. Does that help? Yes, we have algebra, but if we have an isosceles, Isosceles means that two sides are the same. And equal is this symbol for congruent. Congruent and equal are the same. Congruent just kind of goes not just size, length, but also shape. Same shape, same size. But if you're talking about sides, you only have length because they're straight lines, so obviously they're the same shape, right? So it's an isosceles triangle with AB is congruent to BC. So AB is here, BC is here. So that tells me these two sides are the same. Since they're the same, they're equal. And then we're going to solve from here. Subtract 2x from both sides. And I get 2x minus 3 is equal to 5. We'll add 3 to both sides. You know, always the opposite of what's there. And you get 2x equals 8. And I divide by 2. And that tells me that x equals 4. So I found x. So we found x, and we need to find the length of each side. If x is 4 and this side is x plus 2, it's 4 plus 2, so it's 6. Now these are the same length, so I only need to do one of them. We can do 4x minus 3, or we can do 2x plus 5. Well, 2x plus 5, you don't have to subtract, so we'll do that one. So we'll do 2 times 4 plus 5, so that's 8 plus 5, so that's 13. And since this side is 13, and we know these two are the same, that side's also 13. Okay, here we have an equilateral triangle, and since it's equilateral, that means all three sides are the same. So you pick any two, and you set them equal to each other. So you just look at the numbers that are here and you decide which ones you like best. So which one do you like best? 3x plus 10 and 4x plus 1, or 5x minus 8 and 4x plus 1, or 3x and 4x? Okay, we'll use the small ones. Okay. Subtract 3x from both sides. So I get x plus 1 equals 10. Subtract 1 from both sides, and you get x equals 9. Now, because they're all the same length, I only have to find the the length of one side. And then that's the same answer for all three sides. So I can plug that 9 in to the 4x plus 1. And so I would have 4 times 9 plus 1. So that's 36 plus 1, so 37. So this side is 37, this side is 37, and this side is 37. I'm going to run through them really quickly. And then I subtracted 6x from both sides. And then I got 3x plus 2 equaled 8. Subtract 2 from both sides. And I got 3x equals 6. Dividing by 2 gave me that x equaled, dividing by 3 gave me that x equaled 2. I did that dyslexically. Okay, so x was 2. Then I plugged in 2 here, and I got 6 times 2 plus 8, which gave me 20. So this one's also 20. And then 3 times 2 minus 1 is 5. So I have a 20, a 20, and a 5. Any questions on that one? All three of these are equal, so I'm just going to pick one. Well, 2. Always got to be 2. If these aren't the sides you picked, you'll still get the same answers at the end. So it's okay if you picked two different sides than I just picked. It's fine. You'll still have gotten x is 9, no matter which two sides you picked. And 18 plus 6 is 24, so all of the sides would be 24. Okay. All right, so the triangle angle sum theorem, I'm not even going to list that in really official terms. The triangle angle sum theorem basically says this: all the angles in a triangle add up to 180. And as long as we're in Euclidean geometry, which is where we are, you don't get into hyperbolic or elliptical geometry unless you take non-Euclidean geometry in college, which you won't take unless you are a math major. Every triangle will always add up to 180. Basically in this plane of existence where we live. The other two geometries are not in our plane of existence. So in our plane of existence where we live, triangles are always 180 degrees. So we find the measure. This is on the next page. So I think that was page 45, the second page. We find the measure of each numbered angle. So we have an 80 degree, a 73 degree, and some unknown measure. So we just take 180 and we minus the two we have. So we have, it's on the second page at the top. Sorry, the second paper, not the second page. Page 46. 45. Oh, it's backwards. Okay, so we take the 180 minus 80 is 100. Minus 70 is 30. Minus 3 is 27 degrees. So the measure of angle 1 is 27 degrees. On number 2, they only give us one angle, but you see these marks here, how they have the same number of little lines in there? When you have triangles, if the angles measure the same, they'll have the same number of loops. If I have angles that measure different, I'll have 2 different numbers of loops or 3 different numbers of loops. So since these have one loop each, that means they're the same. So I'm going to take 180 and I'm going to subtract 146. So 180 minus 140 is 40, minus 6 is 34. And so these two angles together have to equal 34. So I'm going to divide by 2. So they're 17 degrees. Vertical angles. What do we know about vertical angles? We know something about vertical angles. We've talked about it before. All right, anytime you get an x, the two angles on opposite sides of the x's are equal. So here's our x, and that tells me that this angle and this angle are the same. And if you ever need it, this angle and this angle would also be the same. That's what happens whenever you get an x. You've got angles across from each other as equal. So I know that angle 1 and angle 2 are the same. Okay. So I can find angle 1 using this triangle. I could find angle 2 if I knew angle 3 using this triangle. Because I'm missing 2 angles here, I find angle 1 first. Then that's the same as angle 2. And then I can find angle 3. So I have to kind of move through the triangles. Sometimes they're ordered in order like this. We find angle 1 first, then that tells us angle 2, and that tells us angle 3. But they won't always be numbered in the order you want to move through. So you have to look at the picture to see what angle you can find first. So for angle 1, I'm going to do 180 minus 85 and 40. So 180 minus 80 is 100, minus 5 is 95, minus 40 is 55. Which tells me angle 2. And now I can find angle 3. So I subtract angle 2 and the other angle we have, that's 110, 55 and 55. So 180 minus 110, 70. You're going to have, here's your possible scenarios. Okay? You'll have two triangles that connect together and you get vertical angles. You'll have triangles that do something like this, where the three angles together, this one, and this one, will add up to 180, and you'll have to have two of those to find the third. Or you'll have something like this, where the two angles might add up to 90. And you know one, so you can find the other. So if there's like triangles connected, they'll kind of work in that way. So you'll have equal to each other, they'll somehow add up to 180, or they'll add up to 90. And not that we have to do this, but because this is a straight line, these two would add up to 180. So if I knew this one was 55 and for some reason I had to find this one, I would subtract 55 from 180. So I would be able to find that one if for any reason I needed it. If there was some other triangle that cut across here or something, you had three triangles making a shape. Does that make sense? Yeah. Yeah. So if you needed to, you could find that with the straight line too. So there will not be a picture that we would give you and tell you to find some angle and you would not be able to find it. If I have a triangle and one of the sides extends out, okay, this outside angle is the exterior angle. It is an angle outside of a triangle made by extending a side. That should have been an XT. Okay. So this would be my exterior angle here. Remote interior angles. If something's remote, not like your television remote. Well, actually, I think probably the reason the television remote is called remote is because remote means far away. And you control something far away with your remote. So that's probably why it's called that. But remote is far away, like remote places, remote destinations for travel commercials. Remote means far away. So remote interior angles are on the inside of the triangle, because they're interior, on the opposite side. Putting opposite and side into one word, opposite. I made a new word, opposite, meaning the opposite side. From the exterior angle. So if our exterior angle is here, our remote interior angles are here. They're on the other side of the triangle. So these are the remote. And you can have a situation where, depending on, like if I had a triangle where all of the sides extended, so I did something like, no, not like that. Hold on. Something like that, where all the sides are extending. If I was talking about this exterior angle here, these would be the remote interior angles to it. If I was talking about this exterior angle here, those would be the remote interior. So you find whatever exterior angle you're talking about, and you go to the other side of the triangle. So one angle might be remote in one instance, but not remote in the other. So it's like this angle. This one is remote to here, but it's not remote to here. So you just always jump to the other side of the triangle. Does that make sense? So we have a theorem about these, which is that the exterior angle of a triangle is the sum of the remote interior. Okay, so if I call, draw this again. If I call this angle x, and this is y, and this one is z, x is equal to y plus z. And here's how that works. These three angles make up a triangle, right? And they add up to 180 degrees. Well, these two angles make up a straight line, and they add up to 180 degrees. This angle will be the same in each instance. So if this is 30, this is 150. And if this is 30, these two together are 150, because you have two situations where things are adding up to 180. So that's how that works. But rather than having to, okay, if I have these two angles, and then I find this angle, and then using this angle, I find that angle, you don't have to go through all those steps. If you know these two angles, you just add them together, and that tells you that angle. It's just it's a shortcut. Do you have to use the shortcut? No, you can go the long way if you want to. You'll always be able to solve. Like I said, there will never be a problem you can't solve. You could find this angle and then use this angle to find that angle. That's okay. But if you want to take the shortcut, it exists for you. That's what this is for. It's just it's a time saver. So we want to find the measure of angle 1. Angle 1 is exterior. And these are my two remote angles. My remote interior angles are on the other side of the triangle, so it's 70 plus 55. Angle 2, we have vertical angles. So angle 2 is the same, so it's 55 degrees. So let me do this so we don't get confused. Now I know that this one is 55, and I know that this one is equal to these two added together. So the 150 is equal to 55 plus angle 3. So how I would find angle 3, I would subtract 150 minus 55. Okay, you don't even have to write this part in there. I just wanted to show you what we're doing. So once you have one of these angles and you know the exterior, you subtract one from this one, and that tells you that one.